Hey everybody, David here. So we are at Forgeline Wheels. We brought the Superbee down here. We're going to get it test fitted for wheels. So let's unload it and we'll go find Dave and get some measurements for you guys.
So Forgeline, yeah, I owned another company called Wheel Source where we were a distributor, wheel distributor of brands like BBS and Momo. And we noticed during that time that there wasn't really true custom offset racing wheels that you could purchase other than BBS. And BBS was dealing with most of the major big race teams, Trans Am, that type of stuff. Didn't have time or didn't really want to deal with smaller players or even some of the professional stuff, but just not major teams and stuff like that. So our first wheel, we started Forgeline. It was we bought the forged center in the shape of the wheel. So we had two designs. They were forged in that shape. We had them polished in California and we brought them back here and we literally welded them with an automatic welder into the position to make the offset work, and then drilled the lug holes and stuff like that. So it was a relatively simple process, but it was a fully custom offset wheel with big brake clearance that was designed specifically for race cars. So that's how the business started. We got a lot of the World Challenge field and a lot of the professional racers that really did quite well right off the bat, but it was strictly racing wheels for a while. I mean, we're really the only wheel manufacturer in the U.S. that has cars on professional race teams. I mean, the Corvette GT3R, Chevrolet Pratt & Miller Corvette, that's a worldwide GT3 professional race car. It runs on Forgeline wheels. So we have this heritage. We've been doing this for 30 years. Professional teams and manufacturers are choosing Forgeline for their race cars. So the people in the Optima series and NASA and SCCA feel comfortable with us as well. That's the easiest way to, Bear, Brembo, AP Racing, all those guys. We have good relationships with all of them. We can pull, as long as you know that kit number, we can pull all the information we need, at least on the brake. Not always on the hub, typically not on the hub. So we would typically, especially on the front, a lot of times you have this big hub that sticks out on the front, and we have to cover that hub. Just to go through it, we would just measure, you're going to measure the hub, so it should be about 70.3. To get the height of the caliper, and it's the height of the caliper is the measurement from this to the actual mounting pad. Okay. So it's pretty simple. I mean, you're just going to lay a straight edge, and if you had another ruler or something like that, you could just lay the ruler there. But I'm going to do it. We need the caliper height. We need to know from the center point to the outside here. And sometimes it's easy to figure out, something here, but since we know the diameter of this already, you can just measure from the outside to the outside. It's about 9¼ inches. And then obviously we deduct half of that.
Okay.
And then so same thing. We want the measurement from here to here, and we want the measurement from here to here.
Okay.
So then that we can create this. We know the position of the brake. We know how high it sticks out. We know how long it is. We can kind of create this brake out of. It's not exact, but
the one from here to here, is that to know like if the wheel needs to come in?
Correct.
Right here,
how much of an angle? Right. We're gonna lay our profile over this box that we're going to draw in CAD or whatever, and we're going to lay our profile to make sure that it clears this corner.
Got it, okay.
Needed to. And then you just kind of, you want to turn the wheel, and you need to measure the distance between on this side from where it's going to hit.
Yep.
And then same way backward.
Okay.
The harder thing to determine without one of those wheel measuring gauges is how far you can come out in a situation that you have where it could potentially hit.
I have a Speedway Motors thing where
Right.
I can hook it to a 315.
And those are the best things to really use to do that if you have that.
Okay.
Otherwise you're trying to kind of figure out where it's going to sit just by eyeballing it to a certain degree, which we've been pretty good at. But.
Well, the wheels we make are custom made to order, so we don't mass produce anything. What we stock is forgings and rim halves or rim shells. And when someone comes to us with an order and says, I want such and such wheel to fit such and such car, like I want this AL301 to fit this 70 Superbee, we have to engineer the fitment, figure out what combination of parts that's going to need, and then we pull 4 forgings off the shelf. We custom machine them for that specific person, that specific application. We finish it to their specifications. We assemble it just for them. So when it's all done, they have 4 unique wheels made specifically for their project. Depending on the car, I mean, you know, someone comes to us and says, I have a 2025 Porsche 911 GT3 RS. Okay, we don't need to we know what the fitments are for that. Those are relatively easy to knock out. They're still custom made to order. We don't stock wheels for that application, but we don't necessarily need to measure it. But technically, the process starts up where you walked in the office, because the sales team has to collect a ton of information from the customer. What are you building? In your case, you know, what chassis are we using? What brakes are we using? Have you modified the fenders? It's a 60-year-old car. Has it been wrecked at some point in 60 years? Is the left side and the right side the same? Often it's not. But in a situation like yours, where, you know, this is a unique Superbee. It's got a unique history. It's got a unique chassis. It's got a unique brake combination. You know, hopefully we'll do more of this combination, but maybe not. Maybe the next one that comes in has Bear brakes. Maybe the next one that comes in has Alcon brakes. Maybe the next one has AP Racing brake. Maybe the next one has a Roadster Shop chassis. We don't know. So, you know, that's why I say the process really starts with the sales team. They need to collect all that information, figure out what hubs you're using. How long is that spindle length? Do we need to get over that in order to put a center cap on it? How big are the brakes? What do we have to do to get around that brake? What tire ideally does this guy want to run? Does that tire exist? I mean, that's one of the questions we literally have to ask, because we have people come to us and say, well, I want to run a such and such. And Mark says, where are you going to get that? I don't know. Well, I don't know that that tire exists. Maybe you need to run this other such and such. So that's part of the process. And that's really where it starts, is collecting all that information, figuring out, you know, is this tire available? What do we need to do to fit this specific car? You know, how do we need to machine the center? What inners and outers are we combining? What colors does this guy want to do? So that's the start of the process. So, and then that of course has to go through engineering. We need to check those brake profiles. Is this going to fit? Do we know this brake? Do we not know this brake? If we don't know this brake, we need to go to that brake manufacturer. Can you send us the schematics for this particular brake kit? So it's very involved before we even start cutting aluminum. And I think that's the part that a lot of people don't understand. And the other part that people don't understand is that they don't necessarily need to come to us with fitment specifics. And a lot of people think they do. They think they need to come and say, well, I want a 18 by 12 with, you know, 4-inch front space, 8-inch back space, whatever, and in a 0mm offset or a 20mm offset or whatever the case may be, right? They don't need to know all that in most cases. In most cases, what they need to tell us is, I'm running this chassis, I'm running this brake kit, I'm running this spindle, this hub, and I want to run this tire, and then we can work from that to figure stuff out. So now, once we get that figured out, that's where we start talking about cutting aluminum.
What kind of aluminum are these?
6061 T6, it's technically a proprietary blend. We buy our forgings from an aerospace manufacturer in California, and they have been making forge lines for aerospace applications for many decades, and they have a slightly proprietary formula, but it's basically a 6061 aluminum heat treated to a T6, but with their special sauce. The centers, in your case, because you're doing a 3-piece wheel, so you know, in a modular wheel, we cut the center, and then that gets bolted to a spun aluminum inner and outer, right? In a monoblock wheel, we're carving the entire wheel out of a single forging. Okay. And when we take the tour on the other side of the building, you'll see both those processes. But in either case, whether it's the center or whether it's the monoblock wheel, what we actually stock are forgings. We have a whole nother building over here. You saw it when you pulled in. All that's ours too. Okay. And one of those units is just forging storage. And these are forgings. We have to stock a huge collection of forgings because we have to have forgings in every diameter. We have to have forgings in the monoblock cases in every width. We have to have forgings for every profile or every shape of the wheel. Like this is a concave forging here, where it's got this little dip in it, concave shape. Well, that's a different forging that we would use for a wheel that doesn't, a wheel that doesn't have that concave shape would have a flat forging. So we have to have all those. We have to have all the different shapes, all the different diameters, all the different widths. You're working from a forging. The forgings are going to be stronger, holding all else constant, just because when they're forged and that big press comes down and bangs all that aluminum into the tooling, it tends to align all the grains and it tends to bang out all the porosity. Okay. So you can make a wheel with unaligned grains and lots of porosity strong as long as you make everything really thick. Got it. That of course makes it heavy. Yep. Or you can make it really light, but that of course makes it really not strong.
Yep. And then you add heat in from road track and things like that.
Lateral loads and flex and fatigue. The benefit of the forging, building it from a forging, is that because it's already strong, it's stronger holding the material quantity constant, okay. Right? So for a given amount of strength, we can use less material, thus make it lighter, or for a given amount of lightness, we're gonna have more strength. Yep. So to pick your poison. More often than not, like when a race team comes to us, a professional race team comes to us, their number one concern is deflection. Gotcha. Because they've got, if you're running a modern slick, and modern slicks are so sticky, and they've got modern aero, which is like nothing we saw 30 years ago when we started building wheels. They've got so much lateral load going into those cars, so much grip at the road surface, that the driver can feel that deflection. If that wheel moves relative to the tire, right, if the whole wheel flexes, that screws up a lot of the other handling dynamics of the car, and the driver can perceive that, and drivers don't like it. Yep. They want everything to be, the entire system to be as stiff as possible. They want that wheel to be stiff, they want the suspension to be stiff, they want the chassis to be stiff. So typically what happens to us is the teams come to us and say, we need a wheel that is going to be in the ballpark of this deflection target. That's our number one priority, and then of course we need it to be as light and as strong as possible around that. But we can weight optimize it for a given deflection and strength target. Okay. And we're obviously going to, because of the forged aluminum, we can make stuff, the spokes. What's going to determine the spoke thickness is going to be those deflection and strength numbers, but we can make them as thin and as lightweight as possible around that defining characteristic. Yeah. So figure that out first, pull the right ones, and then haul it over to the other side where we start cutting chips. This is the three-piece side that we're on right now. So everything that's being machined on this side by definition is a three-piece wheel. Okay. So step one of the machining process is what we call a lathe turn. So he'll take those big ugly forgings that we saw over there, he'll stick it in this machine to do the front side, and that just cuts it down to be what it's going to need to be in order to finish the wheel. And when that's done, he takes it out, sticks it in this, and cuts the back side. And the back side is arguably even more important because that's where he's going to cut like the pad thickness. Every order that comes out of here is going to have a different pad thickness. So he'll stick it on this lathe and cut all that. They come out of there being shiny because that's freshly machined. Okay. He's done doing both sides on the lathe turn. Still obviously doesn't look like a wheel yet. Yep. That's when it comes over to the mills. Mill then will actually cut out the spokes and drill the lug holes, cut the center bore. Comes out of here, it'll actually look like a wheel center. when it does its little tool change, it rotates around and automatically grabs what it needs. Everything that we use in this building, with the exception of the center cap machines, all the major wheel machining is done on Hass. So I think the longest ones that we have would be like a 4-hour machine time. The fastest ones we can do in less than an hour. So it can be a pretty wide range depending on the style and the complexity of what needs to be done. So we really know the GT cars. We're really good at GT cars. So like the cars that most people would know right now, the big one that's having a lot of success is the new Chevrolet Corvette GT3.R. That is racing around the world, and it's like the NASCAR wheels, it's homologated. So if you race a Corvette GT3.R, you have no choice but to run the Forgeline SS1R GT wheel. That's the wheel that was homologated when Chevrolet submitted it to all of the sanctioning bodies. So,
Got it. Okay.
yeah, you don't have a choice.
Got it.
Now, there's one more thing though on the 3-piece side I want to show you. I think you know this, but by definition, when we're talking a 3-piece wheel, we literally mean that it is comprised of 3 pieces, right? You've got the center that we machine, and then that gets bolted to the spun aluminum inner and outer, which is how we're able to get all that fitment flexibility like you need for the Superbee, because we can mix and match, in addition to what we can customize into the center itself, we can mix and match those rim shell widths in 1/2-inch increments. So there's no fitment you can't achieve on a 3-piece wheel. If we can build anything on a 3-piece wheel, because we can machine some of it into the center, and then we'll get the rest of it we need just by 1/2-inch increments on the inner and outer widths. When those all come together, they bolt together. This could be sharp. Hopefully I don't cut myself. So on the back of the wheel, you have holes where the fastener goes to hold it all together. Now what we do that no one else does, this is what we came over here to look at, is we have this station here where we actually take the time and effort to put a helicoil in every single one of those holes.
Okay.
As far as I know, no one else in the industry does that. So most other 3-piece wheel companies, when they bolt it all together, they're just putting the fastener right into the aluminum, which works once. But if you're a race team and you find that you're rebuilding wheels every so often because you're running into things and you're bending outers and you need to replace outers, you don't necessarily want to replace the center. So this comes in really handy for those guys. It comes in handy for street people too if they ever need to do a repair or decide to refinish something, because the helicoil allows you to take that fastener in and out as many times as you want and not gall the aluminum.
Now, is it the same helicoil on most of your wheels then? Like
Yes.
if I damage one, I say, hey, I damaged the one, that you guys can send me one?
Yes, same helicoil. Just one big box.
Okay.
Zip it in with that little air tool, and it's a little bit of a tedious process because literally the guy has to turn the wheel upside down, set that in there, zip, set that in there, zip, set that in there, zip, go all the way around.
Okay.
That's one of the differences too between the, it's very similar between the carbon wheel and the aluminum, right? So in both cases, we machine the center and it just bolts in to the barrel. On the 3-piece aluminum wheels, it's 2 aluminum barrel halves. On the carbon wheel, it's 1 carbon fiber barrel, but the attachment is very similar. But one of the differences is the hole count.
Okay.
So I actually had someone ask me on social media earlier this week, can I theoretically swap out my aluminum barrels for a carbon barrel? Well, no, because the hole count's different. Even assuming that the flange was in the perfect spot, which it probably isn't. Over here on the monoblock side, it's the same process where we've got a lathe turn operation. So just like you saw before, we start with these big, ugly forgings. They're just bigger.
Wow.
Because now we have to make the entire wheel out of the forging, not just the center out of the forging.
Got it.
So these are, 100 to 120 pound forgings. And just like we did on the 3-piece, 2 turns. Do the front side turn, flip it over, do the back side turn. And when it comes out, well, it'll be shiny and pretty. Maybe we'll find an example of that somewhere. But those have already been milled. then, again, just like the 3-piece, watch your step here. Once the lathe turns are done on both sides, then it can go in the mill, and the mill will actually do the part that makes it look like a wheel. So cut out all the spokes, cut out all the lug holes. Like I said, exact same process, just bigger. And the big advantage to the, we were talking about this, Liz and I were, but the big advantage to the monoblock is just that they're really stiff. You know, again, as I mentioned over there, the race teams, that's, especially the professional race teams on modern cars, that's their number one criteria is deflection stiffness. And on a 3-piece wheel, the big advantage is its fitment flexibility, because again, we can mix and match those rim shells, inners and outers, to get any fitment. We can finish those separately in different colors. But there's always going to be a little flex on those attachment points. And on a monoblock wheel, you just don't have that. So if
like a modern car, basically.
Yeah. So when you're talking the Corvette GT3R, or you know the other car we talked about, homologated race cars, the Mustang GT4 is also the really well known. They run the GS1R wheel, and if anybody that races a Mustang GT4 anywhere in the world, it's homologated. They have to run a GS1R. But those cars, again, they're looking for deflection stiffness. The monoblock just doesn't have those attachment points that can flex, so they're going to be stiffer holding all else constant. Typically, the spokes on a monoblock wheel come right out to the edge, so it's harder to bend an outer bouncing off a curb. Now the flip side is, if you bend an outer bouncing off a curb on your 3-piece wheel, you can replace the outer. If you manage to actually break a monoblock wheel, you're done, which is why you had to buy 48 with your Corvette GT3.R. And we talked about the pallet changer that we use for those Corvette wheels. Well, this is the machine that has it. This is that pallet changer. So they can load up a bunch of turnings on this and then let them run overnight.
Okay.
Once a week they come and collect those and pay us for the scrap. But you can imagine how much scrap comes out of a monoblock wheel. I mean, again, these were potentially 120-pound forgings that were taken down to a 19-pound wheel. So 100 pounds of scrap out of one wheel. Yeah. Ready for the next step? Yeah. So when they come out of the machine, they look like a wheel, like these. And they'll queue up here, but these are not quite ready for powder coat. So there's one more step that is required before they go to powder coat, and that's what we're going to do over here. And this is the part that is probably, of all the things we've talked about that are time consuming and labor intensive, this is probably the worst.
Okay.
So every single wheel that we do gets some amount of hand pre-finishing or hand grinding, because we need to get all the any imperfection that comes off that machine has got to get taken off.
Like burrs, things like that.
Burrs, machine lines. I mean, in some cases, depending on what the customer wants, some of those machine lines might be part of the aesthetic look that he's going for, but in other cases it might not be. So we might need to get rid of those machine lines. We might need to get rid of the burrs. If it's going to get a solid powder coat, and we're going to go over to powder coat next, but if it gets a solid powder coat, we can media blast it.
Okay.
And that prepares the surface for the powder coat. But we also have a lot of powder coats that are transparent. So they add color, but you can see through them to see the grains. And that's where this hand grinding operation has to be dead on perfect, because you're gonna see what these guys did underneath that powder coat, because it's a transparent powder coat. So, and now, that's a really popular finish because it looks cool. So a lot of people buy the transparent powder coat. And that just makes this part of the operation that much more critical. So on a situation like that, they'll have specific surfaces that they're gonna brush. And in some cases, they might literally have to take a piece of sandpaper and take their finger and get down into particular surfaces and do it totally by hand. You ready for the next one? Yeah. So at this stage of the game, we got ourselves either a wheel center or a monoblock wheel that has been machined, has been grinded on, pre-finished, so it's ready for powder coat. In an ideal world, it's going to come out of that media blast. In an ideal world, it'll come out of that media blast machine and go straight to powder coat. But depending on the circumstances, it may end up sitting around for a little bit. And if it does, then we need to wash it before it goes to powder coats because we need that surface to be perfect. So that's why we have this wash station. So if they sit around for any length of time at all before they get into powder, then they have to go through a multi-stage acid rinse. I think it's actually soap, acid rinse, or something like that. But yeah, it's really so important. I mean, powder coat is not an easy part of it. I mean, all of this is complicated. Fitments are complicated, the machining is complicated, the grinding room's complicated, take your pick. But getting the powder coat quality good is one of the biggest struggles. And we work very hard to get it right. One of the big advantages of being able to do it in-house is that we have more control. So we can take the steps that we need to get it right, and if we make it wrong, we know it. And we can fix it before anybody else sees it, or at least we don't have transit time. Exactly.
Yeah.
Which, you know, we didn't always have our own powder coat. Right before I started, Dave installed this. I think it was 2010 that he installed his own powder coat line here at Forgeline. So, and now it's grown, and we have more ovens. Now we're getting ready to install another spray booth. So it's becoming a larger and larger operation. But yeah, getting the quality right it's tough. And like I said, in an ideal world, we'd go straight from media blast into the booth. Anyway, over here is powder coat. Obviously, most people know what a powder coat is, but it's a powder-based color that they apply an electric charge to it. That electric charge forces the powder to stick to the aluminum, and they'll coat it in the powder, and then they'll roll it into one of the ovens and bake it. And literally in the oven, it melts onto the surface and turns colors and becomes the powder coat that you expect to see. Another example of that labor intensiveness of the process, because there's certain surfaces that you don't want to powder coat, can't powder coat. So all those have to be masked off, which is what this station is. So, you know, I wish there was someone here doing it for you right now. We could demonstrate it, but you know, it's like a little craft project. These guys have to literally stand here with an X-Acto knife and their special green tape, and they have to mask off all those surfaces that it can't get powder on it. And it's a somewhat tedious process. Some powders are two-stage or single-stage. It depends on how the powder manufacturer designed it. So, and most of the powder we buy is from Prismatic. And that's another thing people don't know too, is we stock, I don't know, 100, 150 colors. But in addition to those that we stock, we can get anything from Prismatic. We do have a minimum order that we have to buy, but the minimum order is more or less what we have to do a set of wheels anyway. So if someone sees a color at Prismatic that isn't one of our 150 stocking colors, we just order for them. It's okay. Well, what I was going to tell you was, so some of Prismatic's powders would be a single stage, meaning the clear coat's built in. Okay. You only have to do it all once. But some of them are a two-stage, so that's when you'd run into the put on the base coat, bake it, go back through, put on the clear coat, bake it again. There's also optional finishes that we offer here that are an additional post-powder coat machining operation, so like an HTM. So on an HTM, you might powder coat the entire thing, but then put it back in the lathe and do a high-tech machine operation to spin off just the slightest bit of material off the face so that you get a freshly machined surface on the outward facing surface, but a powder coated surface on everything else. So in that case, you would spray it, bake it, machine it, then come back to spray a clear coat on it, and then bake it for the clear coat. So Yes, there could be situations where it gets multiple.
Okay.
It just depends on what they order. Okay, then finally, at this stage of the game, hopefully we've got wheels that have been engineered, forgings were pulled, everything was machined, everything was pre-finished in the grinding room, everything's powder coated. We're finally ready to assemble it into a real wheel and box it up. So that's what we're doing over here. So if it's a 3-piece wheel, we obviously have to combine all those pieces, the inner, the outer, the center. You have to bolt it together. Here's where we can ask how many fasteners are in it.
All right.
Antoine, how many fasteners are in an aluminum 3-piece?
40.
40?
39 in the reverse.
39 in a reverse, because one of those turns into the valve stem.
90 degrees.
So we use ARP, American-made ARP fasteners. The default fastener here is a stainless steel ARP. We also have a titanium fastener option. Doing here, you actually putting something together? Or?
Yeah, so we're putting together these
So we'll give him a chance to pull his parts here, and he'll bolt these together for you.
All right. Okay. What do they get torqued to?
25. And the part Apparel, they get torqued back at 18.
So it's lighter, yeah. And the carbon has to use the titanium fastener.
Okay.
I think they get a weird reaction.
Really?
Yeah.
Like chemical reaction?
Yeah.
Really? Huh.
I think it leads to some weird corrosion of some sort. If I don't know, discoloration, corrosion. Something about the carbon and the stainless steel, they don't like each other. I mean,
That's nice. Yes. Cool.
oh, and then, so then our, still have one more phase. Thank you, Antoine. So the other thing that a lot of people don't know is that we can sell and mount tires for them too. So, you know, this is an example. These were just mounted up today. This is a fresh set of wheels going out to somebody. They were smart enough to order their tires at the same time. So they're going to ship out already mounted. And we've got this really nice high-end Corgi touchless tire mounting machine. And the two big advantages of that from the customer standpoint is, one, they don't have to haul their wheels anywhere else when they get them to have it done. Two, it takes away the risk of the tire shop doing damage after they've already received them. We're pretty darn good at mounting tires, and we're very unlikely to damage them, but if we do, we know it before the customer does, and we can just fix it.
Yeah.
Whereas if you've waited 6 weeks to get your wheels,
Yeah.
you paid $8,000, then you waited to schedule your tire mounting appointment, then you loaded them in the truck, you pulled them all the way down there, then they got damaged, now you're starting over. Now you got to put them back in a box, ship them back to us, then we have to fix them. It's a rigmarole. So, and then the third big thing is they are technically a little safer when they ship, because the tire does serve as a buffer for all the terrible things that happen in the UPS process. So we can save the customer a lot of convenience, we can reduce their risk, and we can give them a safer shipping experience, slightly more expensive shipping experience, but a safer shipping experience by mounting their tires for them, and then they can just bolt them on when they get them and be done. We're building the GS1R wheel. The Mustang teams came to us and said, we need to try to, one of the wish list items for us on this wheel is something to make the pit handling easier, because we know we're doing pit stops. That's one of the things that our teams struggle with now. So they asked us if it was possible to do something to make it easier for pit stops. And we thought, well, we'll just get rid of all that material in the center so they have more room for the pit guns to get in there. And, you know, we probably don't, in most cases, don't need that mass in there anyway. You know, the spoke thickness matters more. I mean, we do have to factor that in and make adjustments elsewhere to account for that. But for the most part, that's a free weight saving. We can cut those out. We can make it easier for the pit people. We can save some weight. And so that was a race-driven innovation. But then, as tends to happen, it looked cool. So then we had people saying, well, I like that look. I don't need it. I'm not doing pit stops, but I want that look. And then that ended up, because of that, that found its way into other designs for aesthetic reasons, because it looks racy.
Yep.
But it was originally came about because of racetrack applications and those pit stop conveniences. And now it's found its way into a whole bunch of our street wheels too, just because it looks cool. We didn't look at the center caps. We can go look at the center cap machine, because that's a big part of it. So depending on the wheel, you might be able to put a custom engraving somewhere on the wheel itself. Like that wheel probably is a good example. It's got that nice big flat spoke surface. So you can put Forgeline or some logo on the spoke possibly. But more common is a custom center cap. And we build our own center caps. That's what these two machines do. So literally they feed in this big aluminum bar here.
Oh, wow, okay.
And then it spits out center caps over there. And we can customize. There's a fee, of course, because there's an engineering cost.
Yeah.
But we can customize logos, and we do that often on center caps. Customer pays a small fee. We engineer the logo for them, digitize all that, send it down through the machine, and we can cut a custom logo. And then finally, when we mounted it, we built the wheels, we powder coated the wheels, we've assembled the wheels, we put the tires on, then we finally can ship them out the door. And that's what goes on back here. Box them all up, label everything up, and then UPS just pulls to this door here and load them up and send them out. That's the process, top to bottom. Point two, even if you have something that's really custom that we haven't done before, that we don't know the fitment on, a lot of our dealers can also help with those measurements. That's one of the advantages of going to a dealer, is they'll take the measurements, they'll order the wheels.